Good. Hi, everybody. I'm Jill Buschman with New Buildings Institute here for the AWHI Commercial Working Group call for November 2025. Great to have you with us. We've got a great agenda as always, but let's first read out our antitrust compliance statement. The Advanced Water Heating Initiative is a member-supported collaborative of professionals from across the U.S. This diverse membership includes numerous competitors, and care must be taken to scrupulously abide by federal and state antitrust laws. Members should remember that antitrust compliance, is important at all times. At this and other AWHI meetings, participants should not discuss competitive pricing, profitability, allocating markets or customers, or promotion of a particular product or accessory. Okay, well, great to have you all with us. We've got a really good agenda today. We've got your calendars probably show an hour and a half booked. We have maybe 60, potentially 70 minutes of content today. We'll see how good we do on time, but probably let you all go early if you're planning on staying for the full event. We'll get through our introductions, and then we'll hear from Jill Buschman from Willdan about the California Energy Design Assistance Program and all their central heat pump water heater resources and incentives. Then we'll turn it over to Siva from EPRI to hear about advanced monitoring and performance of central heat pump water heating in affordable housing. And then we'll close with a presentation from Evan Green from Ecotope and Andy McNamara from Carbon Zero Buildings, who's on site and may or may not be able to join us. We'll see, about some really interesting central heat pump water heater system innovations that they're doing in California. So excited to hear all of these sessions. But as we usually do for our commercial working group, we invite folks who may be new to the group to just come on camera and on mic and just let us know who you are and who you're with. If folks returning, please put your name and org in the chat if you so feel like doing. But I'll just leave an awkward moment of silence to see if anybody wants to let us know if they're first time to the group.
Well, I'll volunteer. It's my first time with the group, and then I'll be speaking about the CEDA program and our heat pump initiative today too as well. So thanks for having me.
Thanks, Jill.
Hi, I'm David. I'm with LG. Unfortunately, I can't do the video right now because our virtual PCs don't allow it. But next time I'm on a phone, I will. But that is an accurate picture of me. I promise you that.
David, great. Do you work at LG on commercial heat pump water heaters?
Well, I do. I work on compressors and motors. So yes, cool. The compressor side going into the heat pump water heaters.
Great. Thanks. Travis, go ahead. I see your hand up.
So it's Travis Crawford with Colmac Water Heat. I joined them recently as an application engineer, and I'll be participating in the Commercial Act group.
Great. Thanks, Travis. Yeah, love to connect with you afterwards. It's been a little bit since we've had a manufacturer spotlight with Colmac, so we'd love to chat with you about that. Go ahead, Michael.
Yeah, Michael Fung. I'm with the San Francisco Environment Department, and I help run the BayREN business program, which is a POP NMEC incentive program serving the 9 Bay Area counties.
Great. How are the central heat pump water heater incentives going?
We haven't actually had any projects yet, so just listening in right now.
Okay, sounds great. Thanks. And next, I'm sorry, I can't see your name, MP. Mira.
Hello, Mira Patsarthi with the San Francisco Environment Department as well, and I manage the BayREN multifamily program, so work for all projects in San Francisco, affordable market rate, etc., in the multi-housing sphere.
Oh, very cool. Okay, sounds great. Thanks for that. Any other folks who are new to the commercial AWHI working group? Okay. Well, thanks so much, everyone. If you didn't get a chance, please do put your name and organization in the chat. That's a great way to connect with folks. All right, let's get to some of our announcements. Well, first one is quite bittersweet. I think a lot of you who have worked in the industry or have come to AWHI meetings know Helen Townsend from DNR, a great collaborator and ally. We just wanted to say a huge thanks to Helen as she's off to another adventure, but say a huge thanks for all the amazing work she's done creating central heat pump water heater related resources and really help educate the entire industry on some best practices in central heat pump water heating. Helen, I think I see you in the audience, so I'd love for you to give you a second to on the camera and say a couple words.
Thank you so much. It's been just a pleasure and a privilege to work with this initiative and with Joe and Noah from NBI, to work with Kashmira and others at Bonneville, to work with Adam and other folks, Jeff Wicks at NIA over the years, John Heller at Ecotope, of course. I mean, it really has been a privilege to help to support the market transformation and to bring some of the highly technical information to a wider audience. So I am pleased to say that although our company is now winding down, we will be continuing our utility trainings under a third party. So that's feels really good. And if there's anything I can do to continue to support the market, I would be happy to do so. And I'll put my details in the chat. But yeah, it's been a great pleasure to be part of this. And thanks for the opportunity.
Great. Well, thanks so much, Helen. Yeah, really, really appreciate it. And thanks for all the incredible work over these years. Thanks for advancing the industry. Fantastic. All right. Well, a couple just quick announcements from me, and then we'll turn it over to our program. Just a quick recap. This is our first meeting since Heat Pump Water Heater Day. Hopefully you all were able to catch a lot of the incredible sessions. We'll put a link to all the recordings and slides are on the program page, but we had over 1,100 attendees across the week, which was fantastic. Approaching 70 panelists. We had so many names, great names from the residential and commercial water heating worlds appearing throughout the week. So thank you to all those folks. Lots of orgs posting online, promoting heat pump water heaters. Really lots of good viewership of our resources and recordings afterwards. So thanks to all of you for participating in the 4th annual Heat Pump Water Heater Day. We'll be back next year, but taking a little break, okay? But hope you all enjoyed it and hope you found the content good. Of course, if you have any feedback, positive or negative, please send it our way. We're always looking for that information. Okay, next quick announcement. This is on the residential side, but we just wanted to highlight we did a nice, fun podcast, videocast, and article with Navien that we released this week. They are bringing their first heat pump water heater to market that has a stainless steel tank, amongst other cool things. So there's a live link there on the slide, and a link to our in-depth interview in the slide as well. Okay, I'm just looking to see if John Heller has joined the call yet. I don't think I see him on. We were going to give him a soapbox for a minute, but I'll have to see if he joins a little later. Just a note to say that the leads for the AWHI Commercial Working Group got together in Portland, Oregon a couple weeks ago to talk strategy, to talk about what we did in 2025 and what we think the market needs in 2026. So a lot of great conversations came out of that. We're going to be reporting on that in our all stakeholder meeting in December. But we also did, there was a lot of chat about how it's important to get utility incentives for commercial heat pump water heating and align them around the advanced water heating specification to encourage good practices like M&V for all installations. So we'll see if John joins later. He can articulate that a little bit better than I can, but we'll be following up with a little bit more information on that great strategy session in a couple weeks at the all stakeholder meeting. Okay, so that's enough of me rambling on. I'm going to turn it over to Jill from Willdan now to talk to us a little bit about the California Energy Design Assistance Program, because there's a lot of great resources and incentives for commercial heat pump water heating. So Jill, over to you.
All right. Well, thanks for the intro. And then you got the acronym down right, California Energy Design Assistance, kind of a mouthful, but excited to talk more about our program, what we do, and then, of course, our heat pump initiative. Me. All right. So to give you an overview, our program promotes electrification and decarbonization in new construction and major renovation projects across the state. So we work with different project teams to reduce energy demand and carbon emissions. We support efficient design through technical guidance and then incentives that come through our program. And then we work to accelerate the adoption of clean energy technologies like heat pumps, which we'll be talking a lot about today. So as a lot of you probably know, California is seeking to have 6 million heat pumps by the year 2030. However, today we are a little shy of 2 million. So our program is helping to bridge that gap by supporting new construction and major renovation projects that include heat pumps. We want to demonstrate the costs and performance benefits of heat pump systems. And then we're also working to streamline program participation to make the adoption faster and easier for different customers. And so here are some barriers that have been identified for adopting heat pumps by California Heat Pump Partnership. And so I'll talk through some of those. So they identified relative cost, which includes upfront installation costs and then operating costs for different projects. There's also transaction friction, so complex incentive program design, that's hard to understand. Lack of consistent incentive funding, and then complicated permitting processes that are holding different customers back. There's also market maturity, so low customer awareness and demand. There's contractor reluctance to prioritize heat pumps, and then also a shortage of trained installers. And lastly, there's relative costs that are holding back participation. So limited data availability to inform policy and market efforts. So these are some of the barriers that have been identified. And then the next slide will talk through what CEDA is doing to overcome those. All right, so what we're doing to address those hurdles, we're reducing relative cost. So offering 10 times higher incentives to help offset the upfront installation expenses and then improve project economics. We're working to minimize transaction friction by streamlining participation with a simpler web-based application, which removes requirements for meetings, and then enables incentive lock-in within 2 weeks. Sorry, is my the goal for our CEDA program. We're working to build market awareness by providing on-demand technical support and additional educational resources to raise awareness and build confidence among the all-electric community to help integrate heat pump technologies. We're working to enhance market data by collecting project and performance data to inform ongoing policy, program design, and market development efforts. And lastly, we are now offering a more flexible enrollment timeframe for heat pumps. So now we allow for up to 90 days before occupancy for different heat pump projects, which offers more flexibility than the typical early design enrollments that we usually see. So all these efforts are helping to simplify participation, accelerate adoption, and then strengthen California's commercial heat pump market and hopefully make some headway into the goal for 2030. Next slide, please. All right. So further on our heat pump measures, we're working on developing a heat pump initiative screening tool. And this will help estimate annual energy cost savings, maintenance cost savings, emissions reductions, which we have in the form of trees planted as the equivalent, and then gas infrastructure cost savings as well. So this tool will support informed decision-making and faster project progress. And so the different qualified measures that we'll be looking at include space heating systems, surface water heating, of course, plug loads, and then process loads. All right, so if you have any questions about CEDA program or our heat pump initiative, here is information on our website, and then our phone number, and you can look us up at LinkedIn, of course, and follow along. And we're hoping to have more updates on our screening tool in the next few months. So please reach out if you have any questions.
Thanks so much, Jill.
Yeah.
A quick question for you. If designers are considering it like a central heat pump water heater, do they first need to consult with CEDA for some design assistance, or can they apply directly for the incentives?
Yeah, they can apply directly. So that's how we're trying to help streamline it. Like before, we'd kind of want to look holistically at a project, but with this like heat pump push, we are like if a project team has a heat pump in mind, we're just happy to take a look at that measure alone.
Great. Yeah, I think an important point here to emphasize is Tracy's asking, is CEDA only for new construction, or is this a program available for retrofits?
Yeah, we do renovations as well. It just needs to kind of meet a certain threshold. I don't have those requirements at the top of my head, but we do look at different retrofits and renovation projects.
And there are also other rebates, correct, for retrofits for central heat pump water heaters. There are a
Yes.
couple different ones. Okay. Yeah, we'll try to keep folks up to date on there. There's a lot of rebates in California these days. Nancy's like, how about showing emission reductions in terms of gas water heaters replaced in residential? Nancy, do you want to kind of explain what you were saying there?
Yeah, great. Thanks. Thanks, Jill. That was really helpful, and I'm looking forward to hearing more about the screening tool when it's available. I get why people show things in terms of trees, but I think if we're trying to encourage people to move to heat pumps in general, it would be good to say, this is like we did 100 homes and got them off of gas water heaters. So I just think that would help promote some of the other things this group and your group are trying to do. So you could work with, you could work with Air Resources Board on what a typical, I mean, they have all that data.
Yeah,
if you're
that
wondering.
sounds great.
So,
yeah, like we do show a variety of different metrics and savings, but I think what you pointed to would be a good way to frame it for more people.
Great, thanks.
All right, I'm seeing a lot of other questions, but I guess Joseph.
And actually, we're doing great on time.
Okay.
SEPIDA is wondering if are there utility bill increases when how does CEDA manage potential? Well, I guess it's mostly new construction, although there are some benefits. Any thoughts on utility bill increases?
Yeah, we definitely try to account for that and provide, like I said, a metrics of different savings and costs to kind of help project teams kind of mitigate like what their utility costs would look like, and maybe like other measures too that can kind of offset that. So like when we meet with a project team, we try to look at a project holistically to kind of account for utility costs as well.
Got it. Okay, that's part of the advising process. Okay, Scott's wondering, does and we talk a lot about this at AWHI, but does CEDA include any post-installation monitoring to ensure that heat pumps installed are operating as they're intended?
Yes, we absolutely do. We work with 2050 partners who help meter and kind of just identify the progress those different measures are making.
Okay, yeah, sounds great.
After our whole consulting process, that's part of our requirement.
Okay, yeah, it seems like the right one to make sure they're working well. Great. Okay. Well, thanks so much, Jill. That was a fantastic update on CEDA. A ton of great resources for commercial water heating in California. So really appreciate that. Thanks for being on.
Thank you. Of course.
Okay. Great. Okay. Next, I want to invite Siva from EPRI to talk about some advanced monitoring and performance of central heat pump water heating in affordable housing. Siva, thanks for being here today. And you can either take control of the slides, there's a button at the top of your screen, or I can drive them for you, whatever you prefer.
Oh, okay. Either way works. I am not too familiar with Microsoft Teams, so I'll let you drive if you don't mind.
Okay, that sounds great.
Great. Hi, folks. Thanks for joining. My name is Siva Sankaranarayanan. I'm part of EPRI's Advanced Buildings and Communities Research Program. And our program focuses on doing large-scale field demonstrations of emerging technologies, trying to understand how the results and learnings from that can be adapted towards program design for utilities, as well as for policy measures like codes and standards and building performance standards. I wanted to talk to you all about some recent work that we have done with central heat pump water heaters. This work is a collaboration effort with several of my colleagues. I think a couple of them are here. A big shout out to my colleagues Mazen, Maggie, and Young. They have done a tremendous amount of work in this space, and I just want to acknowledge that. So let's move on. So I think this has probably got some animation in it. Sorry about that. Yeah, so developing central heat pump water heaters in multifamily communities, in our sort of humble opinion, is fraught with issues. This is not something necessarily new for many of you here, but if you keep clicking through it, sorry about that. So there's a whole bunch of issues that pop up when confronted with, especially with retrofitting existing gas water heating systems in multifamily communities with central heat pump water heaters. The principal and the primary one is affordability. I think Jill alluded to this as part of the work that she had done and the survey that they had done. It's the principal problem is affordability, but then there are additional issues like space constraints. Sometimes there are performance risks. Central heat pump systems tend to be somewhat finicky when it comes to certain environmental conditions and so on. And then last but not least is the split incentive problem. And if we just click one more time. So what it effectively does is that it makes the whole idea of central heat pump water heating in multifamily communities, it's a lot more of an art than a science. And this is exactly the problem that we at EPRI are trying to kind of tackle. And what we want to do is to try and extract as much science out of the, having done this a couple of times, to be able to extract some learnings and then develop some mechanisms that can potentially help with that. So next slide. In the next slide, what I want to do is to talk about what we are trying to do in terms of solutions. So the comprehensive sort of approach that we're taking to this is to try and address each of the pain points that are associated with the end-to-end sort of retrofit process, if you're doing a retrofit, for example, right? The first order of business is to understand and do a better job of modeling the outcomes, energy modeling, and this is where my colleagues like Maggie have spent a considerable amount of effort in looking at what is the most appropriate tools. In general, our thesis is that if you take the standard tools that are available for code compliance, they tend to be somewhat, they're not as good at being able to do the right levels of prediction in terms of performance, and that means that sometimes they over or underestimate the performance, and that's sometimes causes an issue. There's a big challenge associated with sizing and the location of heat pumps and sizing of the tanks and the swing tank and sort of the systems associated with it. We have also found.
Just a reminder to folks to mute, and I'll try to mute anybody who is not able to do that.
No worries. Just wanted to make sure that this wasn't a cry of pain from somebody who's experienced a central heat pump water heating problem. The monitoring we find to be very important, and this is again having done work in this space where we have tried to scrimp on monitoring and then realizing, oh my God, this is a terrible idea. We should actually develop some templates for monitoring. And last but not least is the whole idea of dashboarding to get the necessary insights, not just for us as engineers and researchers, but more for the maintenance staff, so that the monitoring that's put in place can also indicate to them where they need to go and fix if there's an issue, especially with cost overruns and so on that happens. So iteratively sort of develop these best practices and kind of decompose this rather complex problem into multiple stages. We are hoping to come out with what we call a playbook for central heat pump water heating, and hopefully coming out as a publicly available deliverable for in the March of next year timeframe, which sort of encompasses aspects of various of these little problem steps that we have tried to address. So I want to talk about an actual project that we are working on. If you go to the next slide. So this project is a large community in Southern California, in the San Diego district. It's a community of 192 affordable housing units in San Marcos. They had a gas water heating system which was replaced with central heat pump water heaters. It's 12 buildings, 16 apartments each building. And the good news is that we were able to get this entire project funded at zero upfront cost for the community, largely through a series of sort of braiding a whole bunch of incentives through LIWIP, SOMA, and SDG&E's own funds that were available, incentives. This was supported through our partners, AEA, and the on-site staff that were helping this and doing the engineering and the maintenance on this was Bottom Line Utility Solutions. So again, a big shout out to all of them. And the thought process here is what the basic design was sort of converting the gas water heaters with central CO2 heat pump water heaters with a large storage and stratification tank and a swing tank, along with mixing valves and recirc pumps. So that design is in the next slide, I believe. The system construction, again, it's 12 central gas boiler systems that were replaced. We installed it in 2022. We started monitoring it for performance, and we realized that the performance was not as good as we thought it should be around the first quarter 2023. This was quite a painful exercise because we realized that there was very significant cost overruns. And then so we had to start doing a series of engineering optimizations. And then we also then decided that we will go and apply a proper monitoring in place, not just for the energy use, which was what was originally monitoring, but also for temperature and flow, so that we can get a better characterization of the performance of the heat pump itself and the system as a whole. Next slide, please. So there's a system. We have 3 heat pumps supporting two large tanks, a stratification tank and a storage tank, and then a swing tank, which was then feeding into a recirc pump and a mixing valve to distribute water. So it's very standard. It's almost a standard design, I would say. The key aspects here, we're trying to understand the sizing on the heat pumps and also to try and understand the sizing of the storage and stratification tanks. This is also in San Diego with a very steep time of use rate differential between the on-peak and off-peak rates. So we wanted to ensure that we were trying to reduce the amount of electricity used during peak hours. And so we had to size the storage and stratification tanks and also understand the sizing on the swing tank itself to get that sort of better performance. So here's what happened when we went about installing the system in the next slide. We noticed that the electrification resulted in some pretty high costs. What you see in blue is the previous year, or the average electricity pre-retrofit costs, and then, the KWH energy used, and then the post this is the first 4 months of the performance. So clearly, this was a huge issue. This was no way comparable to the models that were developed. So the initial modeling was done using code compliance modeling software, which unfortunately, I don't think had the right set of parameters in place to kind of help us do an accurate modeling. So this was definitely a challenge for us. On to the next slide. So that energy use increase resulted in significant operating cost increases as well. And so this were the first 4 months. And so we had to do something. So the active optimization that ended up happening was a series of engineering sort of rules that were put in place. And we'll talk about that in the next set of slides. The biggest challenges that we sort of started encountering right away was the heat pumps were and the gas and the storage tanks were inside an enclosure, and the enclosure temperatures were extremely low for the operating conditions. So there was a huge differential. Even in winter in San Diego, the ambient temperature is not that low, whereas inside the enclosure, the temperatures were much lower. So that was first of all a major challenge, and we had to put in place mechanisms to start ventilating that space as quickly as possible and as efficiently as possible. The second was we started noticing that the swing tank was being used excessively compared to the heat pumps, and we had to understand why that was the case, and also to see if we can actually put in some rules to help with that. And then the biggest challenge was some of the heat pumps, which were supposed to be doing the heating, actually showed zero energy use, which was and this wasn't just in one building, but it was actually across multiple buildings. So it's a combination of factors that potentially impacted the operational irregularities that we started observing, and we had to start putting in measures to kind of correct it. Next slide. So the couple of things that we started doing, the first thing that we did was to do some active set point intervention on the swing tank. The swing tank was originally set to 140 degrees Fahrenheit for distribution temperature. Of course, we had a mixing valve, so we had to down mix the distribution temperatures. So we reduced the set point to 110 Fahrenheit. And thereby reducing the amount of mixing that needed to happen on the cold water side. So that definitely helped with reducing the amount of the amount of swing tank use. But also, as you notice on the left and the right, there is one of the heat pumps that is actually consuming zero electricity, and this is a problem, because this means that the work that is supposed to be doing, that the swing tank, that the heat pump is supposed to be doing, is now being taken over by the swing tank, and that also needed to be corrected. On the next slide. So we worked with the manufacturer and helped to kind of, turned out that there was a firmware issue that was causing the problem, so we were able to help with that. And putting those into play, what happened is when we then started looking at comparing energy costs, we started getting a much better picture. So the other comparison that we decided that we would be more sort of more representative to make would be to compare the actual DHW electricity bills with what would be considered as business as usual if you were to use a comparable system, right? So that was the secondary challenge, was you really cannot compare apples to oranges and oranges to apples. You need to compare some level of apples to apples, and this allowed us to get a better understanding of really whether whether the energy costs increases were a result of just because we were using electricity, or it's because of the inefficiency in the system. But this was also a time where we didn't have much of an idea of what inefficiencies were due to. So that's where we had the idea of additionally ratcheting the additional monitoring in place. So that's in the next slide, we'll talk a little bit about that. So we started looking at, on the next slide, please. We started looking at trying to do a little bit more of a robust data collection, right? So right now we were monitoring the energy use through the use of CTs. We were individually monitoring the heat pumps and the swing tank, but we also developed a template to start monitoring the flow and the temperature of the at least the inlet temperature, as well as the DHW temperature, as well as potentially getting at least a proxy of the swing of the tank temperatures. The challenge, of course, is that this was already an installed system, and looking at monitoring that was intrusive would necessarily have to, we had to shut down the water heating system to do that, and instead we decided to use non-intrusive monitors. The good news is that we were able to find a package of non-intrusive monitors on the temperature as well as the flow side. So we instituted that. And then we developed a process to not just backhaul the data from the energy monitors, but also the flow and temperature monitors. And then we also said, we talked to the community, and the community expressed interest in having some amount of visualization of the data so that they can understand the performance. And so this was, that's part our next step, which was to develop a dashboard. And so we started looking at how to do that. So we started, so if you can just go through and click through the whole thing, sorry. So we started looking at we had this temperature and flow data as well as energy data, and we started looking at how do you develop these sorts of dashboards with the idea of doing one of two things. We needed some amount of real-time visualization, and this is important. And by real-time, I don't mean minute to minute, but the ability to know what happened yesterday. So the thought process is that when maintenance staff are sort of confronted with a situation of, hey, my water temperature was terrible yesterday, or why is this happening? Why is that happening? They needed a quick way to understand what was happening with the temperatures, with the tanks, and with the heat pumps yesterday and day before. So that's what we call the real-time visualization. But there's also a need for historical visualization. Historical meaning much larger time frame, maybe a month or maybe a couple of months out, to compare the performance over time, so that they can actually get an understanding of what happens with the heat pump as it's being used. So we've kind of developed this sort of two-stage visualization mechanism. There's a understanding real-time performance, as well as understanding averaged hourly performance over time. We developed a profile of what we call the quote-unquote COP profile on an hour-by-hour basis. How is this, how is the performance of the overall system changing? And then how do we actually then start using engineering rules that can potentially help with being able to potentially shift energy use towards times of higher performance. And in the process, what we also realized was that we could not only provide information about the performance to the maintenance staff, but also be able to do something like an abnormality alert. So, for example, we attached a couple of abnormality monitoring with respect to swing tank use, as well as temperatures. So we were able to indicate to the staff if there was excessive swing tank use, or if the temperatures were out of whack. So sort of taking all of this into consideration, I can show you a couple of slides that last two slides, which are focused in on what happens when you put in these monitoring. So with the dashboard helps us to see in real time what happens. If you just click through a couple more times, please. It has information about profiling on the temperature and the flow side. So not only do you get an understanding of and these the good news is that the Grafana dashboard allows you to zoom in on certain aspects. So you can select timelines, you can select time windows, and you can start zooming in as necessary if there's a need for that. But we also started looking at what happens, looking at hourly profiles. So hourly profiles on temperature, hourly profiles on flow, hourly profiles on what we call the COP. So that's in the next slide. This kind of shows the real time and the hourly energy profiles. So the first order of business that we developed was we developed what we call a system COP metric. So the thought process here is that yes, we have very high efficiency heat pumps, but we need to understand what happens between the cold water intake and the hot water output. The whole system as a whole, what is the level of performance of this? What is the efficiency of this? And that was what we had on the top left corner. And that was dynamically updated based on the window of time that you're looking at. So if you looked at a whole month, you'll get the entire for the whole month. Whereas if you looked at it over shorter periods of time, it could be up and down. In addition to that, we also developed a profile that shows a 24-hour performance on this quote-unquote system COP. Addition to that, we also showed the hourly data on the heat pump and the swing tank use. And on the right-hand side, we developed the sort of anomaly indicators. For example, in this particular case, it looks like there was a fair amount of the swing tank power was reasonable. It's only 32 watts of swing tank power that was used for the window of time here, but the swing tank, the amount of minutes was fairly high. So these are some of the indicators that can potentially tell the maintenance staff exactly what's happening, and the maintenance staff we're continuously sort of engaged in the process of developing these dashboards so that they can get something to them that is meaningful for them to kind of look at and see and figure out what they can do based on that. So that's what we have done so far, and we are taking this to the next step in sort of developing a process to hand off this dashboard to the maintenance staff at the end of the project. So project's wrapping up March of next year, so we're going to hand it off to them, and we are going to train the on-site support staff for understanding how to use this dashboard. We're also sort of developing a process of being able to figure out how to do this on a turnkey basis, so that we can not only help this particular community, but perhaps other utilities, and they can, they help their large communities that they are working with as well, or whoever needs sort of central heat pump water heating. For sure, how do you develop this monitoring template? How do you develop this dashboarding template? And what we want to do with all of this is to take all of these learnings and put together what we call the central heat pump water heating playbook with that. So that's where we are. So happy to take questions, and I don't know if I've gone over my time limit, but sorry about that if I did.
No, thanks, Siva. That was a really great presentation, and we've got I think we've got a couple minutes for Q&A, and then we'll probably go a little bit longer than 1 p.m. Pacific. Great. I see a question from Todd. I had a lot of questions myself, but let's go to Todd's first. What was the heat pump water heating operating cost compared to natural gas boilers operating cost? What approximately COP is needed for parity if gas operating cost was lower?
Yeah, that's an excellent question, and that's very much dependent on the prevailing gas and electricity prices in San Diego. It's almost that you need at least, I think, if my colleague Mazen is on, he has actually done this sort of characterization. I think we looked at it and we said something like 5.5 or above was needed to kind of break even or to make it really work. Yeah, Mazen's on the call. Sorry, Mazen, go ahead.
Hey, Mazen Daher here, also part of the EPRI team. Yeah, I want to agree with Shiva. I think as far as the COP that is needed for clarity, that is very much dictated by what utility service territory you're in, what state you're in, and EIA has data on essentially the gap in pricing between electricity and natural gas, and so the COP that would be required in order to achieve parity is chiefly dictated by that gap when you're electrifying, at least, or when you're looking at the cost of electrification.
Yeah.
This is Todd with Idaho Power. I am the one that wrote the question. Kind of curious. Yeah, I realized that. I was curious if they did it for San Diego, because it's like for here in Idaho, we're at 72 cents a therm versus 12 cents a kWh, and our sister states are at 100 or say $1.25 a therm. So I know it varies, but I'm curious if you all looked at it in San Diego.
Yeah,
it's around a factor of 4 to 5, I would say.
Okay,
just
thanks.
off the top of my head.
Thank you.
Right.
Great. Yeah. Well, let's get to the dashboard a little bit, Shiva. Adam Gage is asking about on this slide the COP drops to 0 at a certain point, maybe hour 9, what would cause this? No hot water demand?
Yeah, most likely that there's just not much water demand. It could potentially also be because there's no use at all. So which is also dictated by water demand. Because it's a central system with a storage tank, the input and output are buffered heavily, so it's not directly correlated to the use of the hot water. But so if you look at the flow profiles, it'll sort of we monitor the flow profile as well, which is not here in the slide. So that gives them additional insight as to why this is happening.
Yeah. You know, a lot of your experience resonates with a lot of the studies we've seen or conducted at AWHI with the turning down swing tanks, rooms getting too cold. And I'm just wondering, Scott, I see you putting a question in there. With, you know, this looks like a really helpful dashboard. I know Ecotope has created the Eco Dash, and then manufacturers potentially have their own dashboard. What's the synergies between these dashboards? How do we get something that's useful for the end user?
Yeah. So this is, again, the dashboarding idea is nothing new. As you rightfully pointed out, there are others who've done similar work. I think what we wanted to do here is to see if we can develop a reasonably priced template for doing this non-intrusive monitoring and then dashboarding together, and also to see if we can develop because this is an open source dashboard, to be able to then tech transfer this onto others who can potentially take advantage of it, and so incorporate it into things like programs, if need be, for large central systems.
Great. Well, fantastic, Siva. Thanks so much. I think if folks have additional questions, please, put them in the Q&A, and Siva, you could maybe check those out.
Yeah.
But yeah, really.
Right.
Really aligned in our, I think a lot of projects have seen some of the challenges that this one did, but great to see the resolutions and some of the learnings that you have out of that. A key point of the crucial nature of M&V for these systems to understand what's going on, how can we improve COP and bills, and so thanks for coming on and sharing that. Really appreciate it.
Of course, appreciate it.
Keep us posted on that dashboard too. So on the playbook, yeah, let us know when that playbook is ready, and we'll get that out to the working group. So, okay, well, thanks so much again to Siva, and I'm going to now welcome Evan Green, and I think Andy McNamara is on the line even from the field to talk about some really innovative, again, sticking with California, some really innovative system innovations with central heat pump water heating. Evan, go ahead.
Yeah, thanks for having me, Joe. And yeah, I'm really glad to be here and hearing about the really good work EPRI's doing. There was a lot of resonance between what we're working on and the things that we're seeing with swing tank systems and the stuff that we're considering our dashboards compared to what you're showing here. So I'm really glad that people are thinking about this because it's so important to get that monitoring in. And I'll talk about monitoring a little bit today as well. And also really happy to see that there's a push to simplify the incentives in California, because it seems like there are a lot out there, but it's a very complicated process to take advantage of those. So yeah, I got invited on today, and I'm super grateful to be here because I get to essentially brag about all of the cool work that Carbon Zero Buildings is doing and talk about the really great research that we've been able to supplement their work with through this relationship that we've created over the last couple of years. And I know Andy was going to lead this presentation, but he's on site right now, so I'm not sure if he'll be able to chime in or not. So I might give him
I'm here.
Okay.
I'm here,
great.
if you can hear me. But yeah, thanks, Evan, for that intro, and completely agree. And Evan's the best person to go through this stuff anyway. But I'm in and out of boiler rooms right now, preparing to electrify another gas-fired system. So I got to focus on that and let Evan share these details.
Okay, great. Yeah, thanks, Andy. Yeah, so Ecotope and Carbon Zero, we've been working together so well, and it's been so personally satisfying for me because I really love diving into the details of these emerging technologies, and I've been able to focus on heat pump water heaters for several years now, and I've been able to do it in a very unique position because us at Ecotope, we've leveraged funding from NEA and BPA and many utilities to really dive a lot deeper into how these systems work and to be able to think about them for a lot longer than your typical engineering firm would if they were just trying to get designs out the door. Because that extra time and money we can spend really diving into these systems has made a huge difference on understanding how they work. And so that's how we operate, is we really dive into these systems through research, and then we use that to inform designs that can be scaled up to the general market. And then we can go back and monitor those systems, so then we can have this closed feedback loop. Anything that didn't quite work out very well through our commercial design team as they implemented these practices, or through the monitoring data we're seeing on site, we can see that, and then we can refine our next level of design. And we're doing all of this to support this mission, as many people on this call are, to accelerate the adoption of low carbon solutions. And that's why I love having this partnership with Carbon Zero Buildings, is because they are doing this at such a high speed and such a high scale that they can really prove that these systems can work reliably and efficiently and be installed without too much burden. So we work really well together that way. And so Carbon Zero Buildings can do this design build process, and they can leverage incentives in California, as many people have seen through here. They can leverage these incentives really well to refine these designs and put that extra thought into these designs, and then be able to sell them to building owners at a very reasonable price. So the combination of those factors, and the fact that Andy and Greg at Carbon Zero have so much knowledge about these systems, like so much more than any other general contractor I've ever met, really drives this great feedback loop where we can input our ideas from Ecotope, from all the research we've done and this foundation we've built, and then get that great feedback from Carbon Zero Buildings consistently as they're implementing these designs and refining on a weekly or monthly basis as they're installing these systems. So I can shout out some of the design innovations that Carbon Zero Buildings has implemented in at least in the last couple of years that I've been working with them. And so one big one is they've really been able to build on the foundation of what NEA has been working on through the advanced water heating spec by implementing several different AWHS diagrams or schematics, like the return to primary, the swing tank schematic, and the parallel temperature maintenance system. They've been able to build upon those with some help, and with our continuous partnership in establishing those designs. So really refining designs based on those foundations, and then figuring out how you can go even a step further to make these systems more efficient and more reliable has been key there. And so a couple of ways that they've gone beyond those baseline schematics are parallel stratified storage tanks. They've tried those on several sites, and we've seen the industry lean towards in-series storage tanks to maximize stratification. But as long as these tanks are being piped well, Carbon Zero is having really good luck having really well stratified storage tanks piped in parallel to both minimize pressure drop and make these heat pumps run a lot more efficiently. And another cool thing that they've done is this parallel temperature maintenance system, but the way they've taken that a step further and made their designs less expensive is to use the integrated CHP 120s that I'm sure have been featured in this group before. And implementing monitoring that we'll talk about in a second has really helped them confirm that these systems are working really efficiently and not just running in electric resistance mode all the time, which that's probably the biggest fear with integrated heaters, since they have that electric resistance element. But they've been able to refine those set points based on the loop temperatures and the system operation that they're seeing to show that we're not running electric resistance. We're actually using heat pumps to heat this temperature maintenance loop. And that's been huge on these retrofit buildings where there's actually a lot of heat loss, and we can't do much to minimize that without doing major building renovations. And then finally, what I think is really cool that they're doing is this solar thermal plus heat pump water heaters. This has always been very challenging of an idea because solar thermal is usually preheating boiler systems, but we know that we don't want that warm inlet water going to the heat pumps, especially in CO2 systems. So they've been able to leverage this on-site solar and pipe it in a way where it's working in parallel with the heat pumps to charge stratified storage instead of preheating that water to feed the heat pumps really hot water and make them run inefficiently. So instead of what many folks have to do when they install these heat pumps is, many folks just have to rip these systems out, even though there's been a lot of time and money put into installing those up front. Carbon Zero is able to reuse these and get really insane efficiencies out of these systems by leveraging that existing solar thermal and retro commissioning to make sure it's running how it's supposed to. And so the reason that they know that these designs are working well and why this process has been so personally satisfying to me among all the other important benefits is we're actually seeing how well the systems are working in real time. And that's all through this controls and monitoring. So using a central controller to be able to refine system set points and then integrating monitoring into that to see how well these systems are actually doing has made a huge difference in the transparency in these systems, figuring out what tweaks are actually driving big differences in the operation, and also proving to potential future system owners of these large buildings portfolios, hey, they've installed several of these systems and we have enough data to show that these are working really well. And because there's a big fear in California that I think you touched on in the last presentation, there's definitely a spark gap where if you switch to electricity, even if you're twice as efficient, it's going to be more expensive. So that's a big fear for current building owners. And installing monitoring like this and seeing this long-term trending data is making them a lot more comfortable in saying, yes, I will install the system because I know there are others out there that you've installed that are working really well. And the fact that this monitoring is just baked into the retrofit design, like we have electrical monitoring just baked into the electrical drawings, and then we have all the sensors where they need to be in a really clean low voltage plan set that Carbon Zero's put together. That means the implementation of this monitoring equipment has been really strong. And and another great thing about this is in their monitoring points are in compliance with the advanced water heating spec. So whose target is to make sure that we can calculate all the performance for these systems, calculate the system COP, as Epri was talking about in the last presentation. So these are compliant with that, so we can capture the entire system COP as well as the heat pump COP using the equipment method and seeing all these monitoring points in real time, all these temperatures throughout the system to make sure that we're serving hot water reliably. So that's been huge in this iteration process. Okay, and the last thing that I really want to call out here that has been really great to see Carbon Zero buildings take on is an unpressurized storage design. And this, I'll show you 3 iterations of this design, and this is just such a big example of how quickly they can iterate to make these systems more efficient and to make them less expensive and easier to install, which is huge for this market. So back in February at AHR, Andy saw this unpressurized storage at AHR and was like, this seems like it could be a lot cheaper to install than these other systems we've been doing. Unpressurized storage tanks are very cheap per gallon. And so we were able to work together and come up with designs for these unpressurized storage systems that work for their upcoming sites. And on Ecotope side, we were able to leverage this research that we had been doing through public funding on unpressurized storage to be able to inform some of these designs as well. So we were able to leverage that, and here's the first iteration of what we came up with. That is, we have our main unpressurized storage tank that is charged in a single pass fashion by this heat pump water heater. And then that unpressurized storage, that large tank, is charging a very small buffer tank that's going to serve hot water to the building. And the reason we have a large unpressurized tank and a small buffer tank is because the large unpressurized tank can handle those peaks at in a longer term, like 1, 2, 3 hour peaks. But the small pressurized buffer tank means you can have a smaller heat exchanger because that is buffering those very short-term peaks, like the 1, 2, 3 minute draws that may exceed what your heat exchanger can provide. So that was the first revision, is this unpressurized storage with a buffer tank. But then Andy and Greg said, well, that's a lot of coil in the tank when we're scaling up to these really large buildings, and it starts to become less doable when you're serving really large load by just immersing a coil in the tank, because it's a relatively low heat transfer. So then the second iteration, which is now installed already, is an external heat exchanger. Now we can transfer a lot of heat in this very small envelope by having the external heat exchanger that's still charged by the unpressurized storage tank, but it's pulled out and put into a prefabbed box with the pumps and controls. So it's installed correctly every time with this prefab setup. And I forgot to mention too, the heat pump itself its pump and controls are also prefabbed, and we're able to circulate the water through a multi-pass heat pump in a way that we can actually charge the unpressurized storage in a single pass, which has been huge in maximizing the amount of energy we can get out of these unpressurized storage tanks. And so then the final iteration of this is Andy and Greg came back. They said, we have these smaller buildings, but we can't fit a buffer tank, unpressurized tank, and heat exchanger and pumps all in this tiny closet, right? They were sized for one integrated boiler, not all of this stuff. So we need to make this smaller. And so let's remove the buffer tank and optimize our controls so then we can load match with that heat exchanger. We are making the heat exchanger bigger to make that happen, but this is now on its way for testing to be built and tested with many different flow rates to make sure that you can reliably hit that outlet water temperature before they install this at scale in buildings. So as a reminder, these last 3 iterations of unpressurized storage that is pretty novel in all of these concepts together, this started 9 months ago, and they're on their 3rd iteration with 2 already installed, in parallel with dozens of systems they're installing in the more, I would say, more traditional way. So this is just my shout out to say this has been such a satisfying iterative process we've been able to iterate at such high speeds that we're just getting such rapid improvements and proof of reliability of these heat pump systems. And yeah, finally here's an actual photo of the installation just to prove we're not talking theoretically right now. We have a pump group on the left that is a fully prefabbed pump skid that's serving the heat pumps. We have our unpressurized tank in the middle here that's open right now, but it's usually nice and sealed and closed on the top. And then we have our our pump group on the right with our additional buffer tank, our small buffer tank to serve that 125-degree water to the building. And that's all I have. I know we're over a bit, so I don't know if I'm allowed to answer questions, but I hope so.
Oh yeah, totally. I mean, we usually book 90 minutes, and so we're doing totally great. Yeah, well, that's great, Evan. That's super, really exciting and innovative stuff. We've got a couple questions in the chat, but I'll start us off. You know, with these new tank iterations and all this experimentation, I mean, it sounds like you're getting the team's getting really good efficiencies from all the M&V that's on site. But is cost a big driver too? Are they seeing like lower cost systems that are more affordable?
Oh yeah, I would say that was the first driver of this unpressurized system, is they saw how low dollars per gallon that unpressurized tank costs. When we're talking of 1,000 gallons of pressurized storage that has to, you know, in the Northwest, we have to have a boiler rating for every pressurized tank, and may not be the same in California, but to get that ASME stamp, you're talking a lot of money. So that was the main driver, and I don't have access to their books, but I think we're working a really great direction on much lower cost systems through this design.
Is the goal, I mean, so this is some of the first unpressurized like setups that we've seen. Is that right? And is the goal then that other manufacturers maybe take notice of what's happening in the field and develop systems like this, or is it just, or would this be just done by design teams and innovative building owners like Carbon Zero?
I would say for this to be successful, then manufacturers would definitely have to step up and create these prefabbed pump groups. Is like with the level of evolution of these systems, even the swing tank systems we're seeing, you saw in the last presentation, there are key things that can be missed really easy during installs. So if manufacturers can package these and specify these systems in blocks like we're seeing here, right? Like this system here, we have 6 connections or 7 connections. It's hot, cold, hot water return, and then pipes to the heat pump and pipes to the prefab storage. So there's no way to mess it up. And I think that's going to be key here, because if you try to, on a job by job basis, if you try to design each component in the system, you don't have the time or money to make this cost effective on a job by job basis.
Got it. Okay. Scott is putting in maybe a difference in unpressurized storage versus pressurized, 5 to 10 per gallon as part of this report versus 20 to 35 per gallon for pressurized storage. So that's interesting.
Yeah.
Carmen had a question about, are any of these systems going to be doing any demand response, with thermal storage and load shifting? Is that in the works at all?
Yeah, I don't know if these ones specifically are driven by the load shift incentives that are out now. They may be, but other projects Carbon Zero is doing are incentivized by the load shift incentives. So they've integrated load shift controls into their central controller. So that's going to include this system. And so we can see the same load shift logic as we've seen in the other systems.
Okay. Back to the that interesting setup where that CHP 120 is providing the temperature maintenance. That's curious to me. I thought that's not an ideal use for a heat pump water heater. Isn't it being fed the warm water, and how are you? Yeah, how's it getting around that where that's a problem for other types of heat pump water heaters?
Yeah, it definitely is seeing much warmer inlet water temp. And so we've done lab testing and have a diagram in the advanced water heating spec to align with that usage, which is just feeding the heat pump the recirc water, or feeding a dedicated heat pump that recirc water. And the important point is, especially in these buildings with high recirc loads, we need to have a heat pump that's been designed for warmer inlet water temps, which is primarily driven by its refrigerant, right? R134A doesn't mind warm water temps much at all. it's going to work less efficiently than if it was receiving 60-degree water, but it's still going to work a lot more efficiently than a swing tank that's seeing a high temperature maintenance load.
Got it. And that CHP 120 has R134A.
That's right.
Refrigerant. Okay. While you've got this slide up, you said you were seeing some crazy efficiencies with that solar thermal and heat pump water heater. What kind of efficiencies were they seeing? Do you know off the top of your head?
Well, I don't have them. It's a pretty new install, so they're not totalized, but there were, like this last summer when they first came in, there were periods where the heat pumps wouldn't run for like 2 or 3 days straight. So,
wow.
So I don't know what COP that's going to equate to, but just pumping energy.
That's awesome.
Yeah, it is huge.
Cool. What are the next steps, to really, this working group seems like one great way to do some knowledge transfer. What are the next steps to share some of these really innovative designs and installations?
Yeah, I think we'd have to hear a lot from Andy on that one, on how to do that. But we've submitted for conferences, and we're trying to pursue CalNext projects to really demonstrate this in a more let's see, a more clear scale. But otherwise, yeah, I'd love to hear ideas from this group, as well as, of course, ideas from Andy and his team, because they own this design and this project in the end.
Andy, I don't know if you're still there, but do you have any thoughts? You might be stuck in the boiler room.
Right.
Well,
yeah.
Setting up one of these innovative setups. Go ahead.
Yeah, you might see that on this slide we have our several cartoon level diagrams from the advanced water heating spec, and I can see those fitting. I can see the next level of unpressurized fitting really well into that, even if it's a more foundational design. And then that could be a really strong inspiration for manufacturers to take that on and do their own integration. But yeah, hopefully Andy can come back sometime in the future to this group and brainstorm some ideas on how this one could be scaled as high as possible.
Cool. Well, that sounds like a plan. And yeah, thanks, Evan, and huge thanks to Andy and Carbon Zero Buildings, which, by the way, we didn't mention they won a Hot Water Innovation Prize from AWHI at Heat Pump Water Heater Day for all this great work. So huge thanks to y'all for doing this really innovative stuff and sharing about it today. We appreciate it. Cool. All right. Well, thanks so much. That we are at time. Yeah, we'll wrap up and just say we'll see you at our next one in January. We'll have an all stakeholder meeting in December, so don't miss that. We'll send slides and recording probably early next week to the group. But thanks so much, Shiva. Thanks so much, Evan, for being on today, and hope you all have a great weekend and then holiday next week.
Thank you, Joe. Appreciate the help here. Thank you.
Thanks.
Thank you.